Today we'll be discussing one of the most famous integrals of all time. It is integral 1 upon 1 plus x to the power of 4 dx. So now we all know how to integrate 1 by 1 minus x power 4. So in a similar technique or by using partial fractions, we are going to integrate this particular integral. Alright. So before jumping into the problem, you know very well that the problem is not in its integral form. So it is our duty to factorize the problem. So what I am going to do is, I am going to write a power 4 plus b power 4's expansion. So this one can be written as a square plus b square the whole square minus 2a square b square. Alright. We can write this as a square plus b square the whole square minus root 2 ab the whole square. Alright. So now we can write it as in terms of a plus b into a minus b. So a plus b times a minus b. So the expansion for a power 4 plus b power 4 is given by a square plus b square plus root 2 ab times a square plus b square minus root 2 ab. So I can write it as 1 power 4 plus x power 4 to be 1 square plus x square plus root 2 into 1 into x times 1 square plus x square minus root 2 into 1 into x. So this can be written as x square plus root 2x plus 1 times x square minus root 2x plus 1. Now it is very well that the factors cannot be factorized further. So I can write it as integral 1 by, or let alone the integral. We'll first simplify the expression. 1 by 1 plus x power 4 is equal to 1 by x square plus root 2x plus 1 times 1 by x square minus root 2x plus 1. Using the method of partial fractions, I can use partial fractions over here. I can write this as ax plus b divided by x square plus root 2x plus 1 and cx plus d divided by x square minus root 2x plus 1 is equal to 1 by 1 plus x power 4. So now the problem is to find my a, b, c and d. So 1 equals ax plus b times x square minus root 2x plus 1 plus cx plus d into x square plus root 2x plus 1. Let me first compare the coefficient of x cube on both the sides. So on your left hand side, the coefficient of x cube, there is no x cube term, so it would be 0. On your right hand side, how I'll find is that when the ax term gets multiplied with x square, you'll be getting ax cube. So the coefficient of x cube would be naturally a. And similarly, when your cx gets multiplied with x square, you would be getting cx cube. So your coefficient of x cube would be equal to c. So now the relation that we have established between a and c is a equals minus c. So I can now compare the coefficients, or probably I can compare the constant terms on both the sides. Comparing the highest power and the constant terms are relatively more easier than comparing the other terms. So we are going to start off by comparing the coefficient of x cube and then the constant term now. So the constant term can be simply compared by, when two constant gets multiplied, you'll be getting the constant term. So when b gets multiplied with 1, you'll be getting b. So 1 equals b, 1 is taken from the left hand side, and similarly when I multiply d with your plus 1, you'll be getting plus c. So b plus d. Now let me compare the coefficient of x square. So here you are having ax. Your ax has to get multiplied with another x term in order to get an x square term. Alright. So here you are going to get minus root 2a. Similarly, when your constant term gets multiplied with x square, you will be having your x square term. So minus root 2a plus b. And for your second expression, when cx gets multiplied with root 2x, you will be getting your x square term. So root 2c, and when your d gets multiplied with your x square term, you will be getting plus c. So plus c is equal to, on your left hand side you don't have any x square term, so you will be having 0 over here. So let me club the root 2's together. So root 2 minus a plus c, and this b and d can be added together such that b plus d is equal to 1, which we just saw earlier. So root 2 times minus a plus c plus 1 is equal to 0. And we know that a equals negative c. So root 2 of, when a equals negative c, you will be getting 2c is equal to minus 1. So c is equal to minus 1 by 2 root 2. Alright. So c would be minus 1 by 2 root 2. Now let me compare the coefficient of x term. So on your left hand side we don't have anything, so it is going to be 0. To compare the coefficient of x term, your ax has to get multiplied with a constant term. Alright, so you will be having a, and your b has to get multiplied with your x term. So you will be having minus root 2b. And similarly for your second expression, your cx has to get multiplied with plus 1, and your d has to get multiplied with your x term. So you will be having c plus root 2d. Since a is equal to negative c, since a is equal to minus c, what I can do is I can cancel a and c together. So now I'll be having, when I take my negative root 2b to the other side, I'll be having root 2b is equal to root 2d. So b is equal to d. Now what I can do with b is equal to d, I can use it over here. So b is equal to d, meaning 2b is equal to 1 and b is equal to 1 by 2. So again I can come over here. B is equal to 1 by 2 implies that d is also equal to 1 by 2. So I have found out the value for my b, my d and my c as well. So a equals negative c, right? So a is equal to 1 by 2 root 2. Now, alright, I can rewrite it in such a way that 1 by 1 plus x power 4 is equal to ax. So in the place of a, I'll be writing 1 by 2 root 2 x. In the place of b, I'll be writing 1 by 2. The denominator x square plus root 2 x plus 1, and cx plus g divided by x square plus root 2 x plus 1. So we are going to integrate it now. So let me assume your first integral to be I1 and your second integral to be I2. We are going to solve each integral individually. So let me first deal with I1. So I1 is integral 1 by 2 root 2 x plus 1 by 2 divided by x square plus root 2 x plus 1 dx. Firstly, I can remove the 2 root 2 in the denominator commonly out. So I'll be having 1 by 2 root 2 integral x plus, so since we are having only 2 over here, I can multiply it with root 2 and divide by root 2 in order to have the same denominator such that 2 root 2 can be commonly removed out. So x plus root 2x plus divided by x square plus root 2x plus 1 dx is what I've got over here. Now we are going to use the expression numerator is equal to a times differentiation of my denominator plus b. This is the formula that we are going to use. Numerator is x plus root 2 and a times your differentiation of denominator. Let me differentiate my denominator directly. So this is your denominator as I mentioned earlier. So the denominator's differentiation would be 2x plus root 2 and your b is something that we have to find it out. So in order to find a and b, let me first put x equals minus 1 by root 2. The reason why I chose negative 1 by root 2 is that, just watch, minus 1 by root 2 plus root 2 is equal to a times 2 into minus 1 by root 2 plus root 2 plus b. By plugging in x equals negative 1 by root 2, the root 2 in the denominator gets cancelled and the numerator will be having a root 2. This root 2 and this negative root 2 nullifies each other such that you'll be having the entire a term gets vanished, so the b term can be revealed out very easily. So minus 1 plus root 2 into root 2 is 2 by root 2 is equal to a times 0 plus b. So 2 minus 1 is 1. So 1 by root 2 is equal to b. So I have just found out the value for b. A. Let me compare the coefficient of x on both the sides. So when I do so, I'll be having 1 which equals a times 2. So a equals 1 by 2. So a is equal to 1 by 2. So the x plus root 2 which is on the numerator can now be written as 1 by 2 times 2x plus root 2 plus b is 1 by root 2. Alright, so the entire integral can be now written as 1 by 2 root 2 integral 1 by 2 times 2x plus root 2 plus 1 by root 2 divided by x square plus root 2x plus 1 dx. I can simply divide it, or I can probably take the constant value inside such that it is 1 by 4 root 2 integral 2x plus root 2 divided by x square plus root 2x plus 1 dx plus 1 by root 2 into root 2 gives me 4, 1 by 4 1 by x square plus root 2x plus 1 dx. Now when I differentiate the denominator, you are getting the numerator, right? So I can write it as 1 by 4 root 2 log of my denominator x square plus root 2x plus 1 plus 1 by 4 times. Let me integrate this. So to do this integration, I should complete the square. So x square plus root 2x plus 1 can be written as, we'll have to, so we are having a square over here and 2ab over here. The problem is to find b square such that the square gets completed. So coefficient of x divided by 2 the whole square is what we are going to apply. So root 2 by 2 the whole square, it is going to be simply 1 by 2. So when I add and subtract x square plus root 2x plus 1 by 2 minus 1 by 2 plus 1, I'll be having this one to be your a plus b the whole square plus 1 by 2. Alright, because this 1 by 2 can be written as b square. So I can write x plus 1 by root 2 the whole square plus, instead of writing it as 1 by 2, I can write it as 1 by root 2 the square. So 1 by root 2 square dx over here. Now I can simply use the formula 1 by 4 root 2 log of x square plus root 2x plus 1 plus 1 by 4 1 by x square plus a square's formula is 1 by a. So we should reciprocate the a times tan inverse of x by a plus c1. So your answer is going to be 1 by 4 root 2 log of x square plus root 2x plus 1 plus I can write this one to be 1 by 2 root 2 tan inverse of, I can simplify it as root 2x plus 1 by root 2 by 1 by root 2 plus c1. So you are going to have the root 2 and root 2 in the denominator to be cancelled. So 1 by 4 root 2 log of x square plus root 2x plus 1 plus 1 by 2 root 2 tan inverse of root 2 x plus 1 plus c1. So this is your value for I1. Now we have to find the value for I2. Is this. So let me remove once again 1 by 2 root 2 commonly out. So I'll be left with minus x plus root 2 divided by x square minus root 2x plus 1 dx. I can probably remove the negative sign also commonly out from the numerator. So I'll be having x minus root 2 divided by x square minus root x plus 1 dx. Now the same procedure goes once again. So you can probably skip the video if you know this very well, or if you want a better clarity, just keep watching. So the numerator is equal to a times differentiation of my denominator plus b is the formula that we are going to imply. So x minus root 2 is equal to a times differentiation of my x square minus root 2x plus 1 plus b, so which is going to give me x minus root 2 a times 2x minus root 2 plus b. Firstly, I am going to compare the constant term. So when I compare the constant terms on the both sides, you will be having minus root 2 is equal to minus root 2a plus b, and then I am going to compare the coefficient of x terms on both the sides. So when I do so, I will be having 1 equals 2a. So a is equal to 1 by 2, and when I substitute a equals 1 by 2, you will be having like so. So I can take this term over here. So minus root 2 plus root 2 by 2 equals b, and I can remove root 2 outside. I'll be having minus 1 plus 1 by 2 equals b. So your b would be equal to minus 1 by 2 times root 2. Alright. So your b is equal to minus 1 by root 2. So a is 1 by 2 and b is equal to minus 1 by root 2. So I can write the x minus root 2 to be a times a is 1 by 2 times 2x minus root 2, and your b is simply minus 1 by root 2. So the I2 integral now becomes minus 1 by 2 root 2 integral 1 by 2 times of 2x minus root 2 minus 1 by root 2 divided by x square minus root 2x plus 1 dx. I can do split division. Minus 1 by 2 root 2 times 1 by 2 times of 2x minus root 2 divided by x square minus root 2x plus 1 dx plus, alright, because I am going to, when I multiply these two, I will be having plus 1 by 4 integration of 1 by x square minus root 2x plus 1 dx. So this one is very easy. Here you will be having minus 1 by 4 root 2. When you differentiate your denominator, you are getting the numerator, which is 2x minus root 2. So the answer would be log of your denominator, x square minus root 2x plus 1. And here I am going to simplify it. I am going to complete the square, and when I do so, I will be getting x minus 1 by root 2 the whole square plus 1 by root 2 the square dx. So I'll be having minus 1 by 4 root 2 log of x square minus root 2x plus 1 plus 1 by 4 1 by a tan inverse of x by a, x by a plus c2. So we'll be having minus 1 by 4 root 2 log of x square minus x plus 1 plus 1 by 2 root 2 tan inverse of root 2x minus 1 by root 2 by 1 by root 2 plus c2. So your final answer would be minus 1 by 4 root 2 log of x square minus 2 root 2 x plus 1 plus 1 by 2 root 2 tan inverse of root 2 minus 1 plus c2. So to find the integral I'll have to add I1 and I2 together. So for your first integral, you got it as 1 by 4 root 2 log of x square plus 2 root 2 x plus 1. And in your second integral, the log term was to be minus 1 by 4 root 2 log of x square minus 2 root 2, sorry, it's root 2x. Okay, it is root 2x log of x square log of x square minus root 2x. I must have wrongly mentioned 2 root 2x and this 2 root 2, this 2 root 2. This is your correct form. Alright. So here you will be having root 2x, root 2x, root 2x. And so you will be having root 2x minus root 2x plus 1 and 1 by 2 root 2 tan inverse of root 2x plus 1 plus 1 by 2 root 2 tan inverse of root 2x minus 1 plus c1 plus c2 can be written as c. So log a minus log b is log of a by b. And tan inverse of a plus tan inverse of b can be written as tan inverse of a plus b minus 1 divided by 1 minus a into b plus c. So 1 by 4 root 2 log of x square plus root 2x plus 1 divided by x square minus root 2x plus 1 by 2 root 2 tan inverse of 2 root 2x divided by 1 minus a plus b into a minus b is given by a square minus b square plus c, 1 by 4 root 2 log of x square plus root 2x plus 1 divided by x square minus root 2x plus 1 plus 1 by 2 root 2 tan inverse of 2 root 2x, and here you will be having the 2 and the 2 gets added up together, so 2 can be removed commonly out, so it is 1 minus x square plus c. This 2 can be cancelled with each other. So I hope you learned something new from this video. Subscribe us for more such content. Thank you.